we're going to look at some tests to tell if some series either converge or diverge. So a series is going to be a sum of the terms of a sequence. So remember from previous lessons, a sequence is a list of numbers that are in certain orders that have a pattern. So a series is going to add all of those numbers together. And sometimes you can add an infinite amount of numbers together to get a finite sum, and sometimes you can't. When you cannot, that means that the series diverges. So we have the nth term divergence test. This says that if the limit of a sequence, so just the list of numbers as n approaches infinity, so as we go out with those terms, if those numbers don't get smaller and smaller or approach zero, if that limit does not equal zero, then the actual series will diverge. We don't have a finite sum. And then just to note, just because a sequence gives you a limit of 0, that doesn't mean that the series necessarily converges. So down here, the series 1 over n, that the limit of 1 over n is 0, but this series does not converge. There's no finite sum. So in order to know that it diverges, it does not equal 0. The limit can't equal 0. If it does equal 0, there's still a chance that it'll diverge. So we're going to use that rule to say whether or not this series converges or diverges. So we're going to take the limit as n approaches infinity of the sequence within the series, see what those terms are approaching as we go out an infinite amount of terms. So if you recall some of our limit rules, it says when you're taking the limit at as n is approaching infinity or x is approaching infinity, that's like finding a horizontal tangent line. And you can do that by taking the variables with the matching highest degrees and dividing their coefficients. So in this case, that would be n cubed. So you can take -1 over -3, which gives you a limit of 1/3. So according to our rule up here, that does not equal 0, so that means that this series will diverge. Alright, so that's one way to test divergence. If a series is a geometric series, we have another rule that we can use to test for convergence and divergence. So a geometric series is in the form a times r, the common ratio, to the power of n minus 1 or to the power of n. Either of those forms are geometric. This series is going to converge if the absolute value of r is less than 1, but diverge if the absolute value of r is greater than or equal to 1. And then if you wanted to actually find the sum, like what that would all add up to, it's going to be your first term divided by 1 minus r, your common ratio. So we want to say whether this series converges, and if it does, we want to find what it converges to. So let's see, that's a little messy. Maybe I'll draw it out here. Okay, so we have a little hint that this is probably going to end up being geometric because we've got these powers of n and n minus 1. So we want to somehow rewrite it so that it's in one of these two forms. What we can do is we can split up these powers down here. So that will be, you could really say that that's 3 to the n times 3 to the negative 1. Because remember, when you multiply the same base, you add their exponents. So 3 to the n times 3 to the negative 1. That would be 3 to the n plus negative 1. And that's still divided by 2 to the n, or 2 to the n is still on top. We can rewrite that further by taking the 3 to the negative 1 and making it 3 to the first on top. And then we'll have times 2 to the n over 3 to the n, which we can then rewrite and put 2/3 to the n power, since the 2 is to the n here and 3 is to the n here. So we now have the sequence written as 3 times 2/3 to the n. Okay, that is more recognizable as geometric because it's in one of these forms. So to test its convergence or divergence, we need to take r and compare it to 1. So r in this case is 2/3. So note that the absolute value of 2/3 is less than 1. So using our rule, we know that this converges. Alright, now we want to find its sum, since it does, and we'll use the formula s equals first term over 1 minus r, the common ratio. Oops. So let's figure out what our first term is. So to find the first term, oops, we need to know the original. Okay, we start at n equals 2. So we plug in 2 to our sequence expression to find what the first term is. So that'll be 3 times 2/3 to the second power, which is 3 times 4/9, which is 4/3. Okay, so we can plug that into our formula now. So s will equal 4/3 times 1 minus, or over 1 minus the common ratio, which is 2/3. So that gives us 4/3 divided by 1/3, which is equal to 4. Alright, lastly, we're going to talk about some telescoping series. And this is kind of an interesting way that this series can behave. So you might look at this and say, can this converge or diverge? So we try to use maybe some of the other rules we've learned. If we take the limit of this, we get 0. So that doesn't help us with the nth term divergence test, because that just tells us something when it doesn't equal 0, not when it does equal 0. So we can't use that one. And this is not a geometric series, so we can't use that. So let's go ahead and just start looking at its terms and see if we have a pattern. So first, we're going to use partial fraction decomposition to split that up. So we'll have, oops, whoopsie, -2, oops, okay, and we can split that up into some number over n plus 1 and some number over n plus 2. Alright, so let's use our partial fraction decomposition rule. So we multiply both sides by the denominator here. So we get 2 equals a times n plus 2 plus b times n plus 1, because their other factors will cancel when you multiply n plus 1 and n plus 2 by a. The n plus 1's cancel. Over here the n plus 2's cancel. So we get, let's continue, -2 equals an plus 2a plus bn plus b, and we group the common or the like terms together. So we'll have an plus bn, or a plus b times n, and then 2a plus b are the constants, and we set them equal to the like terms on the left. So there's no n terms on the left side, so a plus b should add up to 0, and 2a plus b will equal -2. Okay, I think I'm going to use elimination to solve that system. You can use your matrices on your calculator if you want. So let's take the top equation and subtract the bottom equation. So that gives me -a, b's cancel, equals 2. So A equals -2, which if we plug that back in, that means B has to equal +2. Alright, so our expression is -2 over n plus 1 plus 2 over n plus 2. And that is our series from n equals 2 to infinity. Okay, now let's see what is happening with that series. So let's start listing out the terms. So we have, when we plug in 2, we get -2 over 3 plus 2 over 2 plus 2 is 4. Okay. And then next term, when we plug in 3, we get -2 over 4 plus 2 over 5. Okay. And then we plug in 4, we get -2 over 5, and then we get 2 over 6. And then we could keep going and going and going. But our last two terms, here, let me shrink this up a little bit. Oops. Our last two terms will be -2 over however far we choose to go, so I'm going to call it capital N, plus 2 over however far we choose to go for the second term. Well, so these basically last two terms will be last. Or I guess technically we won't have a last one because we're going out an infinite amount of terms, but here's our expression for them. So you'll notice that we can go through and say, oh, well, this 2/4 cancels with that -2/4. These 2/5 will cancel. We're going to have 2/6 are also going to end up canceling. So the middle two terms from the, when we plug in the first n equals 2 to n equals 3 and then to n equals 4, like those middle terms are going to end up canceling. So all the middle terms are going to cancel, including the 2 over 6 and this -2n plus 1, so that all we have remaining are the -2/3 and the 2 over n plus 2. So another way to write that is -2/3 plus 2 over capital N plus 2. And we are going to now take the limit and see if we can use, well, let's see, no, actually we're gonna take the limit of that as n, capital N approaches infinity, because our sum is going to be this first term and then the last term, because all the middle terms are going to cancel. So let's see what we get when we do that. So the limit of -2/3 as n approaches anything is -2/3. As n approaches infinity, for 2 over n plus 2, that'll be 2 over a larger and larger number, which approaches 0. So this series converges, and the series is going to converge to be -2/3. Alright, so ways to see if series converge or diverge. You could use the nth term divergence test. If you take the limit of something and it does not equal 0, you know, or if you take the limit of the sequence representation in the series and that does not equal 0, you know it diverges. If it equals 0, we can't use this test. It's inconclusive. If you have a geometric series, so something with powers of n or n minus 1, try to rewrite it in this basic form, and then you can use this convergence or divergence rule by comparing it to 1. And we have this formula to find its actual sum if you know it converges. And then we looked lastly at telescoping series, and that's when the series, if you list out the terms, many of them cancel each other out, and so you're left with a limited amount of terms, which in this case it was just our first and our last term, which we can then take the limit of to find what it actually adds up to, or if it adds up to something. And this was a finite number, so it did converge, and it was negative 2/3. Alright, and I just looked back at the video and I realized I said something that's not quite right. I said that when you're taking the limit as n approaches infinity like this, you're finding a horizontal tangent line. It's actually for horizontal asymptotes. So sorry about that.